Beyond bones, the mind of dinosaurs. When we think of dinosaurs, we often imagine gigantic creatures dominating prehistoric landscapes. But beyond their size and strength, how intelligent were these ancient giants? The answer to this question takes us on a journey through time, exploring fossil clues and comparing these extinct behemoths to their closest living relatives. Birds. Yes, you heard right. The birds we see today, from the little sparrow to the majestic eagle, are direct descendants of theropod dinosaurs. But let and hash 39s go back to dinosaurs. One tool we use to probe their intelligence is the encephalization quotient, or EQ. This gives us an idea of how large a dinosaur and hash 39's brain was compared to what we would expect for an animal of its size. And this is where things get interesting. Take the velociraptor, for example. This agile predator had an EQ that suggests it was quite smart, at least by dinosaur standards. And then there are the behaviors. Some fossils tell us incredible stories. Stories of dinosaurs caring for their young, hunting in groups, and communicating with each other in ways we can only imagine. And let and hash 39s not forget the birds. Every time we watch a crow solve a puzzle or a parrot imitate sounds, we are seeing the legacy of dinosaur intelligence in action. But, as in any good story, there are also mysteries. Despite all the clues and discoveries, there are limits to what we can know. Many aspects of dinosaur intelligence will always remain shrouded in mystery. But one thing is certain. Dinosaurs were much more than just prehistoric giants. They were complex creatures with behaviors, abilities, and yes, even a certain degree of intelligence. Sauropods. Among dinosaurs, sauropods are perhaps the most iconic. These long-necked giants, like Brachiosaurus and Apatosaurus, are often imagined as majestic creatures that grazed peacefully on prehistoric plains. But how intelligent were these giants? Let and hash 39. Yes, start with EQ, the encephalization quotient. Surprisingly, despite their enormous size, sauropods had relatively small brains. Their EQ was very low, well below 1. To put things in perspective, many modern reptiles, such as lizards, have an EQ around 1. So, in terms of brain size relative to body, sauropods, they were definitely at the low end of the scale among dinosaurs. While we cannot directly compare sauropods to many modern animals due to their unique size and morphologies, we can look to large modern reptiles, such as turtles, which have similar EQs. While turtles are not known for particularly complex behaviors, they do display a range of behaviors such as migration, philopatry, and communication. However, brain size doesn't and hash 39 tell the whole story. There is other fossil evidence to suggest that sauropods had interesting behaviors. For example, some trace fossils show that sauropods may have traveled in groups. This gregarious behavior may indicate a form of social interaction or may have been a means of protecting themselves from predators. Additionally, there are sauropod nesting sites that reveal orderly arrangements of eggs in large colonies. This suggests that these dinosaurs may have returned to the same nesting site year after year, a behavior known as philopatry. Ceratopsids. Among the most distinctive creatures of the dinosaur world, we find ceratopsids. These horned dinosaurs, like the famous Triceratops, are often depicted with their impressive horns and large bony collar, symbols of strength and majesty. But what do we know about their intelligence? When examining EQ, or encephalization quotient, ceratopsids show an interesting picture. Their EQ approaches or slightly exceeds 1, indicating a relatively larger brain in proportion to the body compared to giant sauropods. This suggests that, in terms of relative intelligence, ceratopsids may have had an advantage over some of their herbivorous contemporaries. Take, for example, rhinos. These modern armored herbivores have an EQ similar to that of ceratopsids. Rhinos, while not known for their cunning, have complex behaviors, social structures, and a remarkable ability to learn. Beyond pure anatomy, there are behavioral clues that tell us about the life of ceratopsids. Some fossils suggest that these dinosaurs may have lived in groups or herds. This gregarious behavior may have had multiple benefits, from protection from predators to foraging for food. Additionally, there is fossil evidence showing possible interactions between ceratopsids and predators, such as Tyrannosaurus rex. Healed wounds on ceratopsid fossils suggest direct confrontations, perhaps demonstrating some sort of defensive or territorial behavior. Hadrosaurids. Hadrosaurids, often called in #39, duck-billed dinosaurs in #39, due to the distinctive shape of their mouths, represent an intriguing chapter in the dinosaur book of life. With their unique cranial crests and robust bodies, these herbivores walked the Earth during the late Cretaceous, leaving behind a rich fossil history. In terms of EQ, hadrosaurids had an encephalization quotient of around 1.5. This indicates that, although they were not among the most, intelligent, dinosaurs in terms of brain size relative to body, they still had moderately sized brains compared to other herbivorous dinosaurs. The cranial crests of hadrosaurids are particularly interesting. While some theories suggest that they may have had functions related to thermoregulation or sound resonance, others hypothesize that they may have played a role in communication. Imagine a Parasaurolophus making sounds through its long crest, communicating with members of its pack or warning of potential danger. In addition to possible communication abilities, there is fossil evidence to suggest that hadrosaurids may have had complex social behaviors. Some nesting sites show that they laid their eggs in large colonies, similar to how some bird species do today. This gregarious behavior could indicate a form of cooperation and care of the young. Furthermore, fossil evidence suggests that hadrosaurids may have migrated in large groups, moving across ancient landscapes in search of food and suitable nesting sites. Theropods. Large theropods, such as the feared Tyrannosaurus rex, are often at the center of popular imagination when it comes to dinosaurs. With their imposing size and powerful jaws, these carnivores were among the top of the food chain. But beyond their physical power, how mentally evolved were they? The EQ, or encephalization quotient, of large theropods such as T-Rex was between 1.2 and 2.0. This value indicates that, although they had proportionally larger brains than some herbivorous dinosaurs, they did not reach the EQ levels of many modern mammals. For example, an animal like the lion has an EQ that exceeds 4.5, much higher than that of the T-Rex. However, a larger brain suggests greater processing capacity and potential complex behaviors. Some trace fossils suggest that theropods may have hunted in groups, using cooperation to bring down prey. And there is evidence of interactions between theropods and other species, such as healed wounds on ceratopsid fossils indicating direct clashes. And just like some modern birds protecting their nests, there is evidence to suggest that theropods may have engaged in parental care behaviors, protecting their eggs and young. Dromeosaurs. Dromeosaurs, including the famous velociraptor, are often the center of attention when it comes to intelligence among dinosaurs. These agile predators, with their long claws and feathers, are among the closest relatives of modern birds, leading many to speculate about their intelligence and behavior. The EQ, or encephalization quotient, of dromeosaurs is remarkably high among dinosaurs, with estimates approaching values of 5 or 6 for some members of the group. This is comparable to many modern birds and suggests that dromeosaurs had proportionally large brains relative to their bodies. A particularly interesting member of this group is the trudon. With an even higher estimated EQ, close to 6, the trudon is often cited as the smartest dinosaur we know. This high EQ has led to much speculation about his cognitive abilities. If we compare dromeosaurs and trudon to modern animals, their EQ approaches that of some corvid species, such as crows and magpies. These birds are known for their remarkable intelligence, ability to use tools, and complex social behaviors. While we can, in #39, say for sure that dromeosaurs or trudon had similar cognitive abilities, their high EQ suggests they were among the intelligent dinosaurs. The theories of trudon and #39 tool use are particularly fascinating. Considering its jointed front legs and apparent intelligence, some paleontologists have speculated that it may have used sticks or other objects as rudimentary tools to dig up insects or reach inaccessible food. In conclusion, dinosaur intelligence is a fascinating and ever-evolving field of study. Although our understanding of the intelligence of these prehistoric creatures is limited by fossil evidence, what we have discovered so far suggests a surprisingly wide range of cognitive abilities and behaviors across different species. From the modest capabilities of giant sauropods to the sophisticated cognitive abilities of Dromeosaurs and Trudon, dinosaurs were much more than just instinct-driven creatures. Comparisons with modern animals, particularly birds, the direct descendants of dinosaurs, offer further insights into dinosaurs and #39 potential capabilities. Birds, with their remarkable intelligence and range of behaviors, are a living reminder of the astonishing cognitive abilities that some dinosaurs may have possessed. It and #39. It's important to remember that despite our best guesses and analysis, there are still many unknowns. However, with each new fossil discovery and each new research, we come ever closer to understanding the mental and behavioral lives of these extraordinary creatures. Dinosaurs, with their diversity and adaptability, continue to capture our imagination, challenging us to look beyond the bones and imagine a prehistoric world rich in interactions, communications, and, yes, even intelligence.